Today we're going to get into area and perimeter of triangles. I'm sorry, of parallelograms. No, parallelograms and triangles. So let's take a look at this. We've got area of a parallelogram. We have a couple more formulas to learn. They're similar, slightly different. The area of a parallelogram formula is base times height. Now the base and the height always form a right angle. All right, so this is the base, and the height is from a vertex to the base. Because if you notice, the parallelogram is mushed. It's like a Kleenex box that you kind of collapse a little bit. So the height is not 11 inches. That's that side length. The height is from the vertex to the base to form a right angle. So in this case, it is 13 times 10, 130 inches squared. Area is always squared. So when you look at a parallelogram, you want to drop a line from any vertex, because you could go from here, this way. All right? Now, let's do the area of a right triangle on a grid. Now, the area of a triangle is 1/2 base times height. Now we're getting into the formulas where you're going to see B and H a lot. B being the base and H being the height. We call this small b because it is the length of the base, the distance of the base. So let's find the area of this right triangle. Well, first of all, the base and the height always form a right angle. Let's count. 1, 2, 3, 4. The base is 4. The height is 3. So the area is 1/2 times 4 times 3. 1/2 times 12. It is 6 units squared. Now, some of these you might have heard years and years ago, but now we're going to do more with them. All right? So let's take a look at your formulas. The area of a parallelogram, base times height. Guess what, guys? That's the same as the area of a rectangle. Let's connect those. I'm going to do this in a different color. Last lesson, you learned length times width, right? It's the same thing, base times height. They form a right angle, don't they? She's my little rectangle. My rectangle is a parallelogram. You learned that in Unit 4. That's a right angle. So base times height. It's the same as length times width. Whoa, mind blown, I can tell. All right. And I'm going to scroll up a little bit. There we go. Now, let's find the area of this triangle. First, we're going to write the formula. 1/2 times the base times the height. And what did we say? The base and the height always form a right angle. That's how you can tell which lengths to use. Look for that right angle. All right, so the base times the height. There's the base, there's the height. 1/2 times 20 times 6, which is 1/2 of 120. It is 60 yards squared. Not that difficult. Remember, formulas are beautiful in that you simply put numbers in and solve for the one piece you don't know. A formula tells you everything you need to know. You plug in the pieces from your figure. Let's go to the next page. I'm going to make this just a little bit bigger. There we go. All right, this is somewhat similar to what we did last time. You've got a rectangle being removed from a triangle. That's interesting. To create the shaded region, find the area of the shaded region. Last lesson, we remembered You find the total area of the shaded region, or the area of the total shaded region, the area of the unshaded region, and you add and subtract as necessary. So you have the area of the triangle, 1/2 base times height, which is 1/2 of, well, if this chunk is 3 feet, then this must also be 3. So 4 plus 3 is 8. So the base of this triangle is 8. 1/2, 8 times 9, 1/2 of 72, which is 36. That's my shaded area. And my unshaded area is base times height, 3 times 2 equals 6. So 36 minus 6 equals 30 feet squared. You did the same thing. You found the area of 2 pieces and you subtracted. It looked far more complicated than it was. But you remember what you learned in Unit 4 about parallelograms and side lengths. So looking at this unshaded area, if this side is 3 feet, then this side is 3 feet. Because we say a rectangle is removed, so we know it's a rectangle. All righty. Now, this is going to be intriguing. You find the area of the triangle of the parallelogram in the coordinate plane. So you need to draw an altitude. And you can pick and choose. I'm going to take a look at this. And do you notice on this part, I'm going to draw some lines here. This part on the coordinate plane, it goes across 6. The x-coordinate is 6 for both, so it's a nice straight line. I'm just going to count. What's the difference between -2 and 7? -2 minus -7 is -2 plus 7 equals 5. The distance of this side is 5. But if you notice, these are not on the same level. This is not up at -2, and the y-coordinate is not down at -7. So this is where I have to draw my altitude. I'm going to go straight across, and I'm going to make a right angle. And why did I do that? Because I need the height of my triangle. I have my base. My base is 5 equals base. Now I need to go across and find out what this new altitude is, or not what the altitude is. So I'm going to go, what's the distance between my two x-coordinates? -4 minus 6 equals -10. But remember, from way back when, in the beginning of geometry, distance is always positive because you can't go a negative length. So 10 is the altitude. You may want to pause that and think about it. I simply found the difference between the two coordinates, and distance must always be positive. You cannot go a negative distance. You can go back a distance, but it is not a negative distance. That's why the distance between -4 and 6 is 10. So there's my base, there's my altitude. Now let's do my formula, and I'll do that in a different color. 1/2 times 5 times 10 equals 1/2 times 50 equals 25 units squared. So I don't need to see the lines on a coordinate plane. I can do it mathematically. I find the distance between coordinates. I look at my picture. In this picture with this triangle marked in green, if you'll notice, we have 6, -2 and 6, -7. That tells you that that side is a straight line. So you find the difference between the y-coordinates. -2 minus -7, which is -2 plus 7, which is 5. The distance of this side, the length is 5. You draw the altitude from another vertex across to the base. Since we already found our base, you find the distance between the two x-coordinates, which is 10, and then you plug it in the formula. We're going to do that same concept down here. Now I want you to identify the base, calculate the length of the base, draw the altitude, and calculate the length of the altitude. Finding the area is easy because you'll have all your numbers, you plug them in, but I want you to make sure you can find all these other things. Pause this recording, try the math. Okay, so we have a straight line here, so we're going to find the distance between the x-coordinates. -6 minus -1, -6 plus 1 equals -5, but remember distance has to be positive. That's our base, 5. So this is going to be our altitude. Now we're going to find the distance between the y-coordinates because that's up and down. From -5 to 3. -5 minus 3, whoops, helps if you write the right numbers. Yeah, let's try that again. -5 minus 3 equals -8. Distance is always positive. 8 is the altitude. Now, 1/2 times 5 times 8, which is 1/2 times 40. The area of this triangle is 20 units squared. And I say units because we don't have a measurement there. We don't know if it's inches, miles, kilometers, millimeters. We have no clue. So we say units. And that takes care of finding areas of triangles, whether you find them on a coordinate plane, a drawn triangle with lengths, or you find the lengths of the side with the coordinate plane.